Okay, we are at section 3.3, basic vector arithmetic. Um, so let's go to the PowerPoint. This one's a little more involved, and there's more to learn in this little section. Um, basic vector arithmetic. A equals B, vector A equals B, only if A equals B. What are they saying there? The magnitudes have to be exactly the same, but they both have to point in the same direction along parallel lines. Now, what you see in the graph here looks like four different vectors. In physics, those are all the same vector. Vectors can be moved around where they start and the way they point is important, but where you see four vectors, there's really only one. All of those are equivalent because it's just a conceptual construct, and it's not a physical quantity. They all represent the same vector, and they all have to point in the same direction, and they all have to have the same magnitude. You can call them different vectors if you want, but ideally they are all the same vector. Now, vector addition, we use a head to tail method. So we draw A, and at the head of A, we put the tail of B and draw B, and the resultant, the R, is from the tail of A to the head of B. So R equals A plus B. And we'll learn that it doesn't matter if you were to draw B plus A. We'll see that in another slide. It doesn't really matter. You can have multiple vectors, A plus B plus C, and we just use a repeated head to tail method of adding them. So R, the resultant R equals A plus B plus C. We'll see. Here's what I was saying. A plus B equals B plus A. There is a commutative law of addition. It doesn't matter which order that you add these in. You'll get the same resultant. There's a commutative law of addition. Now, if you haven't noticed yet, the vectors are bold-faced with a little arrow on top of them. When I handwrite, when I do like sample problems, I'm just going to write the little arrow. I can't do bold-face. I guess I could make my pen a little thicker, but I'm not going to bother to do that. I'm just going to put a little vector arrow over my vector. And if there is no little arrow, then we're just talking about the magnitude of the vector. Okay? The vector addition is associative. It doesn't matter, as they show here, you can do A plus B plus C, or you can do A plus B plus C. It doesn't matter which order that you put them in. It is associative. Oops, I lost my power. Sorry about that. It is associative. Let's see. This is here. You can see that A plus B is equal to B plus A. You can see the commutativity property of adding vectors in any order. One is you draw A first and then B, and you get the resultant. Then you draw B and then A, and you get the same resultant. So vector addition is commutative. All right. Let's see. Vector subtraction and scalar multiplication. One way to think about vector subtraction is adding the negative of the vector that you want. So if you have A, and if you have vector A, and if you have B shown in the dashed line, if you add, using the head to tail method, the negative of b, that is the subtraction. So we would draw b here if we were adding it to a, the little square says, the square below it. Adding minus b to a is equivalent to subtracting b from a. Now be warned, vector subtraction is not commutative. Okay, vector c equals a minus b is the vector we must add to obtain. We must add to b to obtain a. So c is the a minus b there. Okay, scalar multiplication, it just makes. Oh, I'm sorry. There's a plus minus a is always equal to 0. It's kind of folded over on itself. A minus b is equal to a plus minus b. We're just going through these same steps. And then scalar multiplication, m equals a, you're going to, if m is greater than 1, then you're going to increase a by the factor. If it's 2 times a, then it's twice as long. If it's 1.5 times a, then it's only 50% longer. If it's minus 3 times a, then it's a in the opposite direction 3 times. It will always, unless it's negative, it'll always point in the same direction. If the scalar is negative, it'll change its direction 180 degrees. All right, let's do a quick quiz. The magnitudes of two vectors, a and b, are 12. A equals 12 units and b equals 8 units. Which pair of numbers represents the largest and the smallest values for the magnitude of the resultant vector a plus b? Well, if you have one that's 12 and one that's 8, the largest will be when they line up head to tail on the same line. So 12 plus 8 equals what? It equals 20. So the largest one is 20. Now, what is the smallest? Well, the smallest is if they're on the same line but in the opposite direction. So if A is 12 this way and B is 8 units in the opposite direction, the B suddenly becomes negative, and you're subtracting it, and it would be 12 units in this direction, 8 units in this direction, and you'd end up with 4 units. So it's the answer is C, 20 units and 4 units. And hey, I was right. See, 20 units and 4 units. And these are the maximum that you can get if it's all on the same line, but they're both pointing in the same direction, and one is they're pointing in the opposite direction. That would be the smallest. Okay. If vector B is added to vector A, which two of the following choices must be true for the resultant vector to be equal to 0? In which B plus A equals 0. A and B are parallel and in the same direction. Well, if A and B, they're parallel, and if they're in the same direction, it's gonna be twice. It'll be like 2A. So that's not it. A and B are parallel and in opposite directions. Well, yes, but is that sufficient? If A and B are not of the same value, that's not sufficient. If one is longer than the other, then you're not going to get 0. A and B have the same magnitude. Well, yes, they must have the same magnitude if the resultant is going to be 0, but they have to be in opposite directions. And A and B are perpendicular. Well, sorry, no, they're perpendicular. There's going to be a vector joining the two. So the two answers, they have to be parallel and in opposite direction, and they have to have the same magnitude. So those are B and C are the correct answers. And we'll pick up components of a vector on the next little lecture.